Hi guys. So we're going to continue on with chapter 2 now. Chapter 2 is working into quadratics first and then on our way into polynomials. So looking with chapter 2, we're starting with just those quadratic functions. So we're going to graph two different types of quadratic functions. The first one being in standard form and the second one being in vertex form. So when something is in standard form, it's going to come in this y equals ax squared plus bx plus c form. So this could be, as an example, y equals, so say 2x squared minus 5x minus 2. Okay, basically, quadratic just means that the highest exponent pertaining to a variable is a 2. So we have nothing over squared. So we have two different variables, one squared, one not squared, and then just a constant in the end. That's just a quick example. The way that we start graphing standard form quadratic functions is we find the x-coordinate of the vertex by using x equals negative b over 2a. So when we're talking about the vertex, since we know quadratics make a parabola, or that U-shaped figure, the vertex is going to either be the very, very, very bottom point, or with a parabola that opens down, it's going to be that very, very, very top point. So regardless here, that vertex, either your maximum or your minimum, but to find just the x-coordinate, you use this formula. Then you would have to keep going in order to find your y-coordinate. The y-intercept is 0, c. So when we first start out, we would always grab the a, b, and c values and then go ahead and keep going from there. One other piece of information to remember is if your a is positive, then it opens up. If your a is negative, then it's going to open down. This is one of those really kind of helpful information to know. Basically, because you might start graphing something and then be like, I don't quite know if I'm doing this right. This is going to be something that will help you. Like, am I opening up? Yes, okay, I'm at least started right. Or if you know your A is positive, but you're showing a graph that opens down, you're definitely wrong. You should go ahead and try again. All right, so let's do an example of a quadratic in standard form. No, stop it. Hey, Ben, come back here. Drop it. Good boy. Okay. Sorry. So let's do the example. I want us to graph y equals 2x squared plus 8x plus 7. Okay, so first thing I do every single time is I pull out my a, b, and c values. If we come over to what the standard formula is, I can literally match up where my a, b, and c are in my current equation with what that kind of formula equation is. So my a is always right out in front of whatever variable for x squared, right? That coefficient out in front. So a is going to equal 2. B is always in front of the single x, right? So that here is going to be 8. My c is always the constant on the end. So that here is going to be 7. Okay, so now I can use that information. I know in order to find my vertex, I use the fact that x equals negative b over 2a. So I say, all right, I know my b is 8. So I take negative 8 over 2 times my a value is 2. So times 2. Negative 8 still over 2 times 2 is 4. So keep simplifying this as much as we can. Negative 8 divided by 4 is negative 2. So again, this is my x value, or my x coordinate in my vertex. So far, in my vertex, I have -2, comma something, right? I don't know what my y value is. Anytime I have an x value and I need to find the corresponding y value, I take that x value and plug it into every x in my original equation. So this would be y equals 2. I'm going to use substitution, right? I'm substituting -2 for x. So instead of x, I have a -2 squared plus 8. Again, substituting in -2 plus 7. So first things first, -2 squared. Anything that's negative that we square is going to turn positive. So I get 2 times +4, which is going to be 8. And then we have 8 times -2 is -16 plus 7. Okay, we add up 8 and 7, and then add that to -16. I'm going to be left with just a -1 here. Okay, so my y is -1. Again, the y value for my vertex coordinate. So -2, -1 is my vertex. What I'm going to do is I would start graphing anything once I find it. If I find information, I like to put it on my graph right away. So one, so I don't forget, and two, so I can kind of start thinking about what my graph looks like. So graphing -2, 1, -2 is the x, so I go over -2 and then down to -1. This is my either very tippy top or my very, very bottom of my parabola here. Since my a is positive, right, this is a +2 up top, that means I'm going to open up. So from here, I should go up in some form. The other piece of information I gave you was that your y-intercept was 0, c. My c value is 7. So 0, 7 is a point on my graph. Not just any point, but my y-intercept. So over 0, up 1, 2, 3, 4, 5, 6, 7 is a point. So one super cool thing about parabolas is they have what's called an axis of symmetry straight through the vertex. Okay, so what happens with this axis of symmetry is this is a dashed line, basically. I mean, it doesn't actually exist in my parabola, but what it acts as is a line that if I folded my parabola in half, it would be exactly symmetrical, like it would line up perfectly. So whatever's happening, I know that this point's going to connect up here. So whatever's happening on that, I didn't quite go through my point. Let's try that again. There we go, it's a little bit better. Whatever's happening on this side of my parabola is going to exactly match what happens on this side. So I like to mirror points. Instead of finding more points in this parabola, I like to just mirror the ones I have. That means less work for me. So this y-intercept was over 1, 2, and up 1, 2, 3, 4, 5, 6, 7, 8 from my vertex. So if I opposite this, right, and I'm going to go left 2 and up 8, I've now mirrored that point over my vertex. I can only do this with my vertex. So now I can connect those points and I have my full parabola. Okay, so sometimes we get lucky and we only have to find our vertex and our parabola, or vertex and y-intercept, and then we can be done. Just as a little like heads up, if at some point in time your vertex and your y-intercept can be the same point, or my vertex and my y-intercept are super close together, so I have to find another point, you can always make an xy table and just start finding more and more and more points. Like I could say, well, I want to know what happens at -1 to make a more accurate parabola. So I could plug in -1 to my xy table. Same thing with over here at -3 or +1, right? I could try any of those x values and just make an xy table. All right. So the last one we have to talk about is vertex form. Again, these are all quadratic, so they're still going to be parabolas. They just come, Benton, hey. Okay, sorry about that. The dog's going crazy. So still a parabola. The difference between vertex form and standard form is simply the way in which you find it. So for vertex form, it's y equals a times x minus h quantity squared plus k. So we don't get quite as lucky here because there's not as much that we know about being able to find this really easily. You still have the facts that if A is positive, it opens up, and if A is negative, it opens down. I still am able to find my vertex, obviously, from vertex form. This is H, comma, K. The really important thing to remember is this is a negative H to begin with. So if I put a 1 in here, since this was already a subtraction sign, and I put a positive 1 in, it's going to look like a -1, but my H is actually a positive 1. So an easy way to remember this is always take the opposite sign of H. Okay, so if it was a -1, my H would be a positive 1. If I had a +1, my H would be a positive, or I would be a -1. So after that, we don't know much more about how to find points in vertex form, besides starting to an XY table up to find more points. All right. So let's graph one of those and then we're good. So we are going to graph y equals -2 times quantity of x minus 1 squared plus 2. Okay, so let's identify my A value to know whether or not it opens up or down. My A is -2. What this tells me is I'm going to open down. Oh, you can't see that all that well. There we go. Next thing, let's identify my vertex. Again, vertex is H comma K. This part and this part of my quadratic function. So my H right here is a -1. Again, I always take the opposite sign. So instead of -1, my H is a +1. K always remains the same though. So my K is +2. Let's graph that out. So 1, 2. So since I opened down, I know that this is going to be the very top of my parabola. Something's going to make this go ahead and open down. So I have nowhere else to go from here. So what I have to just start doing is making an XY table. So I like to make educated guesses. There's no right or wrong points to find in an XY table when you're trying to create points for any kind of graph, but there's better points than others. So based on the fact that my vertex is at 1, 2, I want to start thinking what other x values matter to me in this parabola. So you definitely need to choose points close to your vertex. Otherwise, like, does it matter to me right now what's happening way over at -8? No, because that could be way down here, right? Like off the screen even. And then that doesn't give me any idea what happens between here and here along my x value. That's also a really hard point to go ahead and mirror. So we like to stick close by this vertex point. So the point that I'm going to go ahead and try, I could do any of them near here. Instead of just going off by 1, I'm going to go off by 2 of this vertex. So I'm going to try the x value of 3. So what I would do is go ahead and plug 3 in to my original equation, right? This is substitution. So it'd be y equals -2 times 3 minus 1 quantity squared plus 2. So order of operations says, let's do inside of parentheses first. So 3 minus 1 is 2 squared. No, this is okay. In my head, something wasn't going to work out. So now we have 2 squared. 2 squared is 4. Still plus 2 over here. Negative 2 times negative 4 is negative 8 plus 2. I'm ending up with negative 6. So my y value attached to this 3 is negative 6. Let's go graph 3, negative 6. We are all the way down here. Okay, so instead of trying to find, I mean, it's whatever you would rather do. Some people are like, no, I just want to go 2 points this way and test negative 1, do substitution to find that other point. Others say mirroring is so much more easy. We're going to mirror it. So I went over 2, down 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go left 1, 2, and then down 1, 2, 3, 4, 5, 6, 7, 8. And my point is mirrored. Okay, now I'm going to go ahead and draw my parabola. That was kind of an awful parabola, but you can kind of get the gist of it. Okay, so mirror your point. Go ahead and find a second point. The one thing about if you're using an XY table, if I went over to this way to find a point, my next point on my XY table needs to be the opposite direction too. Okay, so I would test 3 and negative 1. Tested 3, my next one would have been negative 1. Very obviously, it would have been down here at negative 6, right, if I tested negative 1. Okay. Okay, so that's it. So basically, this is the process you would take even in standard form if you needed to find more points. Okay. But that is all for 1.2.